type of resistances are available in market. Figure 1 shows 200 ohm resistance and its power is 12 watt, means we can use this for 12 watt circuit only. If you are using higher than this, then this will burn. There are two terminals of it and these terminals are given for the connection. Similarly, figure 2 shows here 4 kilo ohm. 1 kilo ohm means 1000. 40 kilo ohm means 40 multiplied 1000 ohm, and 300 watt resistance, that is its capacity is more than the previous one. And at the bottom there are another three resistances. 10 kilo ohm, if 1 kilo ohm is equal to 1000 ohm, therefore 10 kilo ohm is equal to 10 multiplied 1000 ohm, 1 by 2 watt. Next is 150 kilo ohm, 1 by 4 watt, and 1.5 kilo ohm, 1 by 8 watt. There are colors shown in the diagram also. Here we can observe different colors. These colors give the value of resistance by using the standard formula, and in this way the shopkeepers calculate the value of resistance and they give to the customer. Customer does not know what is the value of resistance. These are the only color bands on which calculation is based for the value of resistance. On the top corner of the slide, we are having different LEDs. LEDs of different color, white color, and at the last red color. These LEDs are used nowadays. They can operate at a very low voltage, say 1.5 volt, then 2 volt, and it depends upon the manufacturing that voltage can be increased also. Their life is very long and they suddenly does not put off. Means if they are going to damage, then their light becomes dim and certainly at zero level. In this way they are useful for us for a long time. The full form of LED is light emitting diode. Next figure shows here diode, anode and cathode, diimaged, and there are electrodes named diode, positive terminal and negative terminal. If you are observing a transparent LED in the last figure, then there is one small electrode longer in the length, that is positive terminal, and shorter one is negative. In this way, electrician or the mechanic can observe which one is the positive terminal of LED and which one is the negative terminal of LED. Below it, there is a figure that shows a triangle and a straight line. It means this is the functioning of LED. Then positive terminal, that is triangle shape. Here another negative terminal are shown here, and current is flowing. Then the LED emits light, and that comes in the shape of arrows shown figure, and that is the energy coming out from LED. At the bottom there is a transformer. Transformer figure is shown in between, and it is showing here two coils. One is primary coil, another is secondary coil. The number of voltage in the primary coil, we are observing primary coil 5 turns, that is 110 volt, low voltage. On increasing number of turns on the secondary coil, that is secondary coil 10 turns is shown the figure, and more number of turns means it is giving more voltage in the output, that is output voltage 220 volt. Primary coil, secondary coils are not in connection, but in between them there is soft iron core. This soft iron core transfers magnetic field of primary coil to the secondary coil, in which secondary coil number of turns we are observing on the soft iron core. There is no direct current passage from primary to secondary by means of transferring magnetic flux, that is magnetic field, from one coil of another coil. Electricity is produced. Transformer can work in alternating current supplied in our houses, villages, towns, from the big lines shown in the various villages. That is alternating current, but it cannot work on direct current, that is having a cell for remote, clock and others, because it is based on principle of induction. Next figure shows here LDR, light dependent resistance. When the light falls on the resistance, its value decreases, current flows, and when there is no light, say at the night, then the resistance increases. And at the last there are two capacitors of black color. These are known for the capacitors made of ceramics. They can be used for storing charge. They can be used for filtering current, that is as a filter, and in various applications used. This slide shows here standard symbols used in the circuits. See another slide showing the standard symbols used in the circuit. Now let us come to resistance. Let us come to definition of resistance. The obstruction means opposition offered to the flow of current by the conductor, which is called resistance. Its unit is ohm, and it is denoted by the symbol omega. Formula: resistance R is equal to potential difference V upon current I. Now 1 ohm resistance can be defined as follows. The resistance of conductor is said to be 1 ohm when the potential difference V across conductor is 1 volt and the current flowing I 1 ampere. Next is conductance. Reciprocal means 1 upon resistance is called conductance, and its unit is also ohm inverse, or letter OHM, just inversed MHO in opposite order of that. Now there are factors affecting resistance of wire. Point number 1, resistance is directly proportional to length of conductor. It means a longer wire has a more resistance in comparison to this smaller wire. Point number 2, resistance inversely proportional to area of cross section. It means a thicker wire has a low resistance, thin wire has more resistance. Point number 3, it depends upon the nature of material. Silver is the best conductor of electricity. Copper is next to silver, then aluminum, iron and others. That is, material also affect the resistance of a resistance wire. Fourth, directly proportional to the temperature of conductor. On increasing temperature, increasing temperature, resistance decreases. This is a problem to find number of electrons flowing in 1 Coulomb charge, or if 1 ampere current flows for 1 second, find the number of electrons flowing in a conductor. Another is definition of 1 volt. Definition of Ohm's law. Physical conditions like temperature remains constant, then the current is directly proportional to potential difference. I varies V or V is equal to IR. Here the circuit shows here is circuit of Ohm's law, in which battery is a combination of cells connected in series. Another RH rheostat has a variable resistance to change resistance value in the circuit. Ammeter A with positive negative terminals to measure the ampere, number of amperes, that is current. Resistance R is a resistance of say bulb connected in circuit, and V is voltmeter having positive negative terminals connected to the battery. This is a graph between voltage V and current I. It is a straight line. Then it is known as ohmic conductor. The VI graph for a conductor is straight line, that is the proportionality between voltage and current. Then resistance is known as ohmic resistance. Two resistance wires are given to us, and they are having the voltage current graph as shown in figure. If slope of resistance is low, means it is far away from voltage axis, then resistance is low. If closer to the voltage axis, that is having high resistance. Figure of green color straight line is giving high resistance because it is closer to the voltage axis, and if we are calculating slope delta V upon delta I, that is more than others. Limitations of Ohm's law, that is conditions at which Ohm's law fails. This is only true at constant temperature. If temperature is changing, resistance is changing, and Ohm's law is not valid for it. In case of changing resistance, we can find resistance at various points, and that is dynamic resistance. Resistance is also changing, not constant. But method is to find resistance is as usual, that is delta V upon delta I is equal to R, resistance R, that is the slope of voltage current curve, give us resistance. Figure 1 shows here straight line of V and I, voltage and current, that is straight line. This shows here ohmic resistance. Proportionality of voltage and current is present. Figure 2, 3, 4, they do not show here proportionality and not straight line between voltage and current, that is non-ohmic resistance. Therefore, in the figure second, third, fourth,